In this video, let's see how to transfer the given network from time domain to S domain and then solving that one using mesh analysis. That is example of mesh analysis in transformed network. For that, let's consider this example. In the network shown in figure, the switch is closed at t is equal to 0. The steady state being reached before t is equal to 0. Through mesh analysis, we need to determine current through the inductor 3 Henry at t greater than 0. So as mentioned in this question, initially the switch was in open condition and the network achieves steady state condition. So it is essential to obtain initial conditions of this network considering the condition of network just before switches get closed. As before switch is closed, that is at t is equal to 0 minus the network was in steady state condition. As we know, at steady state condition, inductor act as short circuit and capacitor act as open circuit. So at t is equal to 0 minus, that is just before switch is getting closed, the equivalent circuit is this one. Here inductance act as short circuit at t is equal to 0 minus. Therefore, current through 2 Henry inductor I1 is equal to 1 by 2 ampere. That is I1 0 minus is 0.5 ampere and I2 0 minus is 0 ampere as the switch is open condition initially. Where I1 0 minus is current flowing through inductor 2 Henry just before switch is getting closed. And I2 0 minus is current flowing through inductor 3 Henry just before switch is getting closed. As we know, immediately after switch is getting closed, that is at t is equal to 0 plus, current through inductor cannot change instantaneously. Therefore, I1 0 plus will retain as I1 0 minus, that is 0.5 ampere, and similarly I2 0 plus become 0 ampere, that is I2 0 minus. We know the equivalent transformed representation of inductor contains an inductor with a value S into L in series with a voltage source L into I0 with opposite polarity as shown here. Here our inductance value is 2 Henry and I0 is obtained as 0.5 ampere. Therefore, S into L become 2S and L into I0 become 2 into 0.5, that is 1. Considering all these concepts, now we can draw the transformed equivalent circuit of this network for t greater than 0. This 2 Henry inductor become inductance 2S in series with a voltage source 1 as mentioned earlier. This 3 Henry inductor become 3S only as initial current through this inductor is 0. And for resistor there is no change. In transformed network their value retain as 2 itself. So this is the transformed network corresponding to the above network. Now let's see how to solve this transformed network using mesh analysis. As seen here, there are two meshes, mesh 1 and mesh 2. Let mesh 1 current be capital I1 of S and mesh 2 current be capital I2 of S. Mesh 1 equation by applying KVL become 1 by S minus 2S into I of S plus 1 minus 2 into I1 of S minus I2 of S is equal to 0. Rearranging the quotient of I1 of S and I2 of S, this equation can be written as 2S plus 2 into I1 of S minus 2 into I2 of S is equal to 1 by S plus 1. Let it be equation number 1. Similarly, by applying KVL over mesh 2, the loop equation can be written as 2 into I2 of Vs plus 3s I2 of Vs plus 2 into I2 of Vs minus I1 of S is equal to 0, or minus 2 I2 of S minus 3s into I2 of S minus 2 into I2 of S minus I1 of S is equal to 0. Separating coefficient of I1 of S and I2 of S, we can simplify this equation as minus 2 I1 of S plus 4 plus 3s into I2 of S is equal to 0. Let it be equation number 2. Now, equation 1 and 2 can be expressed in matrix form like this. This matrix is in the form Ax is equal to B. This A matrix, which is impedance matrix and is the coefficient of I1 of S and I2 of S. And this matrix is B matrix, which is the source matrix, that is elements of this matrix is voltage source in each mesh. In mesh 1, total voltage source is coming as 1 by Es plus 1, and mesh 2 there is no voltage source. Now using Cramer's rules we can solve this equation. In this problem we need to find current through 3 Henry inductor, that is 3S in transformed domain. What is the current flowing through 3 Henry inductor in transformed domain? It is I2 of S. It can be obtained by the relation delta 2 by delta, that is I2 of S is equal to delta 2 by delta, where delta 2 is the determinant of a matrix which can be obtained from A matrix by replacing its second column entries with B matrix. So this is that matrix. Determinant of delta 2 is obtained as 2 into S plus 1 divided by S, and delta is determinant of A matrix, and it can be obtained as 2S plus 2 into 3S plus 4 minus 4. Substituting the value of delta 2 and delta in this expression, after simplifying we can write down I2 of S as 1 by 3 into S plus 1 upon S into S plus 1 by 3 into S plus 2, which can be solved by partial fraction expansion. I2 of S can be written as A by S plus B by S plus 1 by 3 plus C by S plus 2. The coefficient A can be obtained by multiplying I2 of S, that is this expression, with Es and equating S is equal to 0 in that equation. After solving, we can obtain A as 1 by 2. Similarly, B can be obtained by multiplying this equation with S plus 1 by 3 and equating S is equal to minus 1 by 3 in this equation. After solving, we can obtain B as minus 2 by 5. Similar way, we can find out C by multiplying the equation I2 of S with S plus 2 and equating S is equal to minus 2 in that expression. After solving, we can obtain C as minus 1 by 10. Now I2 of S can be written as 1 by 2 upon S minus 2 by 5 upon S plus 1 by 3 minus 1 by 10 upon S plus 2. Taking L inverse of this equation, we can obtain current flowing through 3 Henry inductor as I2t is equal to 1 by 2 minus 2 by 5 e raised to minus 1 by 3t minus 1 by 10 e raised to minus 2t, that much ampere for t greater than 0.